correct? Okay. And so we can then now replace our Tn by 3 and T2n by 3 with our assumed functions. So we have Cn by 3 log n by 3 plus of 2Cn by 3 log 2n by 3 plus of this particular n. And then we come to this particular equation here. So we simplify this equation. I'm going to come back to this equation, how we simplify it. But we come from this equation into this particular equation here. And from there onwards, we have Cn log n plus n times 1 minus C log 3 plus 2C3. And basically that means is for all n greater than 0, this particular term needs to be less than 0. In order to prove that it is big O, we need to say that n log n has to be subtracted by something, right? So that only means that it is big O of this particular equation. So if this particular equation holds that it is less than equals to 0, only then can we figure out whether we have a big O complexity or not. And then we can figure out the values for C and N0. Now, we have two equations here, Cn by 3 log of n by 3, and we have 2Cn by 3 log of 2n by 3. Now, I'm saying, yes, Brian, yes, niece, I want you to use substitution method for that. That is why I extended the deadline. Perfect. I'm not sure about question number part 2 of question 3, but definitely for part 3. Could you remind me what part 2 is again? And while he does that, okay, so let's take this equation. Is anybody here who does not understand how we progressed from this equation to this equation? Mm-hmm. Yes, I can see. All right. So does all of you understand how we get to this equation from this equation? So if you understand, tell me how. Type in the answer. I want one of you. Let's pick someone. Let's pick Kavyashri. So Kavyashri, tell me how I got from the second equation to the third equation. Kavyashri, are you typing the answer, or we can't understand if you're typing the answer? So I think Kavyashri is trying to type in the answer, but while she does that, do you guys understand how we got into the third equation from the second equation? Yes, no? Kavyashri, if you're stuck, you can let me know that I'm stuck, or if you're typing the answer, let me know if you're typing the answer. Perfect. So we have Cn log n minus n log 3, Cn log 3 for, yes, exactly, for the first part. Thank you. And what about the second part? And while she types in the answer, anybody who does not understand how we got to the third equation, and you can say no, that is fine. guys are too shy to answer. No, aren't you? Okay. So as Kaveshir says, we have the first part of our equation, that is Cn by 3 log n. So Cn log n minus Cn log 3, all of those divided by 3 for the first part. Exactly. For the second part, we have, as we see from Kavesh's answer, we have 2Cn by 3 log 2n minus 2Cn 3 log 3, right? Because we are subtracting, because we are dividing. And we have 2 by 3 Cn log n plus of 2 by 3 Cn log 2. And now 2 by 3 Cn log 2 essentially means 2 by 3 Cn, because log 2 is 1. And then basically once we solve all the equations there, we get to this particular equation. If you have not solved it, this is a pretty easy equation to solve to get to this particular point. I want you guys to solve it and figure out the solution. Thank you, Kavashri. That would be more than enough. Thank you so much. So then we have Cn log n plus n, and then we have 1 minus C log 3 plus 2C by 3. That is the leftover part. And now, since we are trying to prove big O, we need to say that this particular equation has to be less than 0, because we are trying to prove big O of n log n. Right. So for all n greater than 0, we need to prove that this particular equation is less than 0 or a negative value, less than or equal to 0, but or a negative value. So then we have to say C log 3 minus 2C by 3 is greater than 1. And from there onwards, we find the value of C, that is 1 divided by log of 3 minus 2 by 3. So we say that 1 by log 3 minus 2 by 3 is greater than 0. Is this equation correct? So in order to prove if this equation is correct, we need to say that this is a positive number. If this is a positive number, then this equation is going to be greater than 0. So in that case, we need to say that log 3 is greater than 2 by 3. So can someone approximately tell me the range for the value of log 3, or whether this equation is positive or negative? So in order to do that, I want you guys to figure out what is log 2 and what is log 4. Assuming that both of those are log base 2, what is the value of log 2 and what is the value of log 4? One, two, any other answers? 1 and 2. So we can assume, exactly, right? So we can assume that log 3 lies between 1 and 2. And we know that 2 by 3 is some number that is less than 1. Essentially, it is 0.66667, but whatever. So 2 by 3 and log 3 is, I think, 1.7. In any case, 2 by 3 is less than 1, and log base 2, 3 is greater than 1, but less than 2. But then we can say that this is positive. So 1 by this particular equation is greater than 0. And finally, if that is greater than 0, we have the value of C. The value of C is going to be equal to 1 by log 3 minus 2, 3. For any n greater than 0, we have now, by definition, T of n is n log n. Thanks, Brian. 1.58. So this is how we proved that using the substitution method, Tn by 3 plus 2Tn by 3 plus n is going to be n log n, or big O of n log n. So let's look at another example. So if C greater than equals to that value, that will write the constant in front of n, thus proving our original assumption. Yes, but remember that n can never be negative. N can theoretically be 0, Ryan, but n can never be negative. Yes, the constant can be anything, but usually the constant is going to be as positive number, because a negative constant in terms of algorithmic analysis doesn't really make sense. So in that scenario, we will see that for all big O, big omega, big theta type of stuff, we assume that C is greater than or equal to 0. Is that what you're asking? Yes, yes, exactly. That particular part needs to be negative when C is that particular value. Exactly. Because in order to prove big O, we need to show that this is negative. Yes. Perfect. Okay, so let's look at one other example. I think this is the one that does, no, this is the one that does work. Okay, so we have 3t n by 4 plus of n squared, and we need to show that it is big O of n squared. So for this, we need to show that t of n is less than cn square for some c, for some n, or basically for some n0. Then we have Tn by 4, and we assume that it is Cn by 4 squared because we have this particular equation, and we assume that it is Cn squared. So we have Cn by 4 squared. So Tn by 4 becomes Cn squared by 16. Then we replace that with our Tn by 4. So we have 3Cn squared by 16 plus of n squared. We take out n squared from this equation. We have 3c by 16 plus 1 n squared. Now, in order to show that this is less than equal to cn squared, we need to say that 3c by 16 plus n squared is less than cn squared, right? So in other words, we have to say 3c by 16 plus 1 is less than or equal to c, right? So we have to prove this particular equation. So by mathematical magic, I mean, you guys can understand how this goes, right? 16, so it becomes 3c plus 16 divided by 16. So we have 3c plus 16 minus 16c. And in general, we have c greater than or equal to, because we are swapping the values and we are subtracting by minus 1. We have c greater than or equal to 16 by 30. If you do not understand how we got from here to the value of c, I want you guys to try it out on your own with inequalities equation. Let me know if you have any troubles. I'm not going to stay here long. And then, therefore, Tn equals to 3n by 4 plus n squared is less than Cn squared because C has a value of 16 by 3 for all values of n, because we are not assuming any value of n for this particular case. And then we can say T of n equals to big O of n squared. Okay. Okay. Now, let's look at a wrong example. So let's say that we have T of n equals to 2t n by 2 plus of n, and then we are trying to prove it is big O of n. We have to prove that T of n is less than equal to Cn. We can assume that T of n by 2 is less than equal to Cn by 2. Then we can say T of n is less than equal to 2 Cn by 2 plus n, which essentially becomes Cn plus n equals to big O of n. Now, what this means is we have this particular equation, that is n times c plus 1 has to be less than or equal to n. Or in other words, we need to prove, not n's, my bad, Cn.